Hi there. Today we are going to talk about cutting tools used for the milling process. So cutting tools for mills. All right, so we're going to learn about the different types of tools um, as well as their different uses and for different processes. So I got a bunch of pictures here that I just wanted to show you here. So here we have an end mill. So this is an end mill. This is another end mill. That's an end mill, and this is an end mill. These are face mills. So we got face mills. We have end mills. This is a drill. So I know I put the title here, but that's a drill. We also have drills, high-speed steel drills. And we have high-speed steel reamers. So this is a reamer. We have taps. So these are all tools that can be used in a mill. A mill can be used as the same processes as a drill press. So anyway, going back to end mills can have any number of flutes. Well, maybe not any number, but they can have from one flute to up to 6 or even more flutes. So this one is a 3 flute end mill. This is a 4 flute end mill. This is maybe a 4 flute roughing end mill. And this looks like a 2 flute ball mill. Might also be called a ball nose end mill. This is definitely a roughing end mill. Roughing end mill has this serrated edge here. It almost looks like a tap, but it is definitely not going to make taps. And then this is just just what we would call a standard end mill. Over here we have face end mills. So notice that these have inserts in them. So these inserts here actually do the cutting, and these are made out of carbides. So a carbide is comes as I believe as a powder, and it's sintered together. The powder is sintered together under high heat and pressure, and then it has some sort of coating on it. It could be nickel, or sorry, titanium nitride. That's commonly what gives this gold finish, but it might have a black finish depending on the coating. These looks like high-speed steel here without any coating on it, and then you have this black coating, which is not a paint; it's actual some sort of ceramic coating that increases wear resistance. So it reduces wear of the tool, which makes the tool more accurate and a batch of parts more precise overall. Below here, I just wanted to show that this is a drill. Again, it looks like it has some black oxide coating on it, but this is a reamer. So this is a reamer. And I wanted to show this tool because a reamer can't actually make a whole feature on its own, but it can enlarge a whole feature from a pre-existed drilled hole. And this hole will be way more accurate because a reamer is a way more accurate tool for drilling a hole or making a hole. So getting back to end mills, I'm going to continue with these, and I'm going to talk about their process. So let's say you actually just wanted a hole feature. So I'll show the material in blue here. So here's I don't know what this part would be used for, but we have a square part and you just have a hole in it. And this hole, you know what, I'm going to draw that in dotted lines because you can't see it from this angle. And this hole doesn't go all the way through the material, but it just goes to a certain depth, and that depth is, it's got a flat bottom. So you could bore a hole out with a 2-flute slot drill. So this is commonly referred to as a slot drill. If it only has 2 flutes, it's I guess you could call it a 2-fluted end mill, but it's commonly referred to as a slot drill. And these, again, end mills can come in metric, they can come in inches, they can come in all sorts of diameters. So with a slot drill, the main purpose of the slot drill is to make a bored hole with a size-on-size diameter. So that diameter would be equal to that diameter. And so you can get a nice flat bottom. So let's say you wanted to make a part that you wanted recessed screw heads. So in this part, you would have a hole that was like that, where the screw head, so choose a different color, would be recessed. Those are the threads of the screw. And so you get that sort of appearance or that feature for whatever you need it for. That would be a good tool to use for that. Whereas a drill, you would get that pointed, that chisel edge, which would be unsuitable for this type of cap screw or a bolt head. So that's an option that you can use, a slot drill. Now, if you want to make a pocket in your material, let's go back to blue, and here's again that same part, and you want to make a pocket in it. And just draw that in. So you want to make this part. You could come down with a end mill that has the same diameter of this. And you come down to the depth that the pocket is in, and you can come across and then come back up. That is one option, although that may not be the best option for finish of the hole of the pocket on this side, or it may not have the accuracy that you want. So another option that you could do if you're doing a pocket, and in this case the pocket is a slot. I'll draw a top view of this part here. Here's the pocket feature that you want. So you could come down with a smaller end mill, come across and leave one radius away from the edge, and then continue all the way around to make that edge. And that will produce a much cleaner and a much more accurate pocket if you do this method. And then you may ask yourself right now, well, what about all of this material? Wouldn't that just make kind of a ring of sorts in the material? You could, on another pass, take all of that material out with some sort of pocketing pattern. Now, that pocketing pattern can change a lot. It can be a spiraling pocketing pattern. It could be an angled pocketing pattern. It all depends on what your application is and the CAM software, the computer-aided manufacturing software, provides. So just moving on, I want to talk about this roughing end mill. So what good is this? It's going to leave a terrible edge on it, on your part. Well, if you need to make pockets very quickly and you have a lot of material to get rid of, let's say you have a part that looks like take up a lot of space on this one. Say you have a pocket that has maybe a shape like that, and it's quite a big pocket, and it's going to take a lot of time on your using a normal end mill. The roughing end mills are used because they can go so much faster than just your standard end mill. So this pocket has a depth that it goes to. So I'll just quickly draw that in a dashed line there. So you could come in with a roughing end mill, go super fast in, I'll use a different color for the tool pattern. You know, don't quite mill out the edge that you want on the pattern, but you could come in and go super fast like that, and then come back with a regular end mill, like this 4-fluted end mill, and then you could just profile out the nice edge of your pocket that you want, like that. So you would make that call if you know, you needed to, if speed was so important. So, which typically it is, but depends on what sort of volume you want. And again, this part has, you know, some sort of thickness. Okay, so one thing else I just wanted to touch on was this. So these have different diameters. It looks like they have different lengths. They definitely have different amounts of teeth. So this is a 4-fluted end mill, and this has 1, 2, 3, 4, 5, 6 flutes on this end mill. So, but the main difference that I see with this is what sort of process you can use it for. So in this one, you see that this cutting edge is continuous across these 2 flutes, but discontinuous on these 2 flutes. So when this tool plunges into the material, just like it would over here, this is going to cut the material continuously. Whereas if you tried to plunge with this tool, you would break the tool, it would just explode, and the material would be damaged as well. And it's all because you are not actually cutting any material here. You're just actually just ramming a spinning tool into the metal. It would be no difference of taking a bar of this diameter, sticking it in the spindle of the machine, and plunging it into the top of the material. I bet you would be very unsuccessful in making a pocket. So I'll just draw what the different applications are for this. So we just draw, maybe the part has a step in it. Just like that. So this tool here, I'm going to talk about this end mill. Oh, by the way, this is called a center cutting end mill, whereas this would just go by end mill. Okay, so if we just use the end mill that doesn't have a center cutting portion of it, I'll just switch to red here. You would have to come down off of the material. So here's the cutter, and then come across, and then go back up. Whereas the other tool, you could come in a little bit closer and cut this material as it's plunging. In this case, it doesn't really matter, but really for that pocketing function, you would not be able to use that tool. You could use the center cutting end mill. So finally, I'm going to just talk about face milling. So these are really meant for taking off the surface of the parts. So let's say you have a cast part. That cast part looks like this. A cast surface is, as you're aware, is very bumpy, and that those bumps come from the sand that's imparting the shape of the part, or imparting its surface onto the part as the molten metal cools. So if you're mating this part against another part, you're probably going to run into dimensional issues, maybe even vibrational issues, where the parts just don't stick together because these bumps loosen. You're just not able to get the holding pressure required because of these bumps. So you can take these bumps down with a face mill. So I'll just sort of draw that same part with a face mill. Feature in it. So if you came across, and this is bumpy here, if you come across, I'll just switch my pen to blue, with a face mill, and the face mill would roughly look like this. And you can't see those carbide cutting inserts because it's rotating at a pretty high velocity. You would calculate the spindle speed, but anyway, you would come across, and by the time that you came across, this whole portion here would be nice and flat, and would be very smooth and very flat by the time that the face mill comes across. So that is one of the main purposes of the face mill. So you're trying to face the top of the part, make it very flat, and you're trying to do it very quickly as well, so in 1 or 2 passes. So I've seen these things, range all the way up maybe to 8 inches in diameter, maybe even more. They go as far down as, um, you know, the, 2 inches. If they go below 2 inches, they may be called an end mill, like a carbide insert end mill. So yeah, that is the main function of a phase mill. So that concludes this video. I hope you um, uh, understand the processes here. I just I want to lead you to these videos here, and I want you to watch these because they're really good. So I posted these videos on the Learn website where this video is located. So these are pretty. The video just shows so much more information.
The FM45 indexable face mill shown here is manufactured by Glacier Machine Tools and uses square inserts tilted at 45 degrees. Each insert has 4 cutting edges and can be rotated 90 degrees to expose a fresh cutting edge.